Hey guys, in this video we will be deriving the Kepler's third law. So let's say that we have a big body here with mass big M, and let's say we have a small body here with mass M. And this small body is orbiting this big body in a circular path. So we are assuming this is a circle. So the big body is going to exert a gravitational force like this on the small body, and the small body has a velocity v, and the velocity is continuously changing because it's going around a circle, so that means it's changing direction continuously. And there is a separation r between these two masses. So because this small body is going in a circle, that means it's going to have centripetal acceleration, and that is caused by the centripetal force, which is caused by gravity. So what we can say is that centripetal force F, which is mv squared over the radius, which is big R, is equal to the gravitational force, which is the gravitational constant, times the big mass times the small mass over the radius of orbit squared. So we have like terms, so the small masses cancel out, and this all cancel out, and the power of 2 cancels out, leaving with just power of 1, right? So how can we go about working the velocity of the small mass? So as I said earlier, the small mass is traveling in a circle, right? So that means the distance it travels is equal to d is equal to 2 pi r, and it will travel that in a time period, let's say t. We know velocity is equal to distance divided by time. In this case, velocity is going to be v is equal to 2 pi r over t. So now we can sub this back into this formula. So v squared is equal to 4 pi squared r squared divided by t squared, and this is equal to g, which is the gravitational constant, times the mass of the big body divided by r. And now we can rearrange this for time period squared, and when we do that, we will get 4 pi squared r cubed divided by gm is equal to the time period squared. So you can see that 4 pi squared divided by gm is a constant, right? So we can say t squared is equal to some constant k, let's say, multiplied by r cubed. This is the same thing as saying that the time period, the orbital time period squared, is directly proportional to the cube of the orbital radius. And this is Kepler's third law. Thank you for watching.